Computer technology and its impact on student achievement in elementary math education. The use of computer technology has become increasingly popular in elementary schools over the past several decades. It is impossible to think of education without also thinking about the many different kinds of technology used to support education. Educational technologies offer potential for engagement in mathematics learning activities and may help to support students' motivation. The National Council of Teachers of Mathematics emphasized the importance of the use of technology in mathematics education, stating that technology is essential in teaching and learning mathematics. It influences the mathematics that is taught and enhances students' learning. In a survey of mathematics research in the United States over the past 30 years, studies found that technology produced a positive impact on students' achievement. However, results also indicated that the effects varied by the type of educational technology used. This review aims to explore educational technologies that are most effective to both educators and students. Successful and effective use of technology for teaching and learning of mathematics depends upon sound teaching and learning strategies that come from a thorough understanding of the effects of technology on mathematics education. The rationale and reason this topic was selected is because as a fourth grade math teacher, researching the most useful and effective technology to help aid in my students' achievement is of extreme importance. To achieve maximum benefit, the way to use computer technology matters. Lee argues any tool, technology, or otherwise simply cannot replace good teaching. Past research on computer-based instruction has shown it to be effective in increasing student learning. However, simply supplying software is not sufficient to achieve success. Knowledge of technology, as well as building pedagogical practice around it, are keys to ensuring the implementation of technology within a classroom. Using technology in classrooms where teachers practice constructivist approach to teaching rather than using technology in classrooms where teachers use traditional approach to teaching aid in mathematics achievement. Constructivist approach of teaching is defined as student-centered instruction that emphasizes strategies such as discovery-based or inquiry-oriented learning and problem-based application-oriented learning. Traditional approach of teaching is defined as teacher-centered whole class instruction. Using CT purely as a way to deliver instruction will not influence student achievement. When teaching with technology, it is not sufficient for teachers to know how to use the technology or to understand the content. It requires that teachers expand their knowledge of pedagogical practices across multiple aspects of planning, implementation, and assessment. Constructivist approach to teaching facilitates technology to impact the learning of mathematics. Students' use of technology enables students to take control of their own learning. Computer technology has been used to create interactive learning environments and learner-centered mathematics classrooms to enhance mathematics achievement. Mathematics achievement refers to performance scores on solving mathematical problems that are measured by mathematics tests, either standardized ones or teacher-made. Researchers have classified different types of CT into categories: tutorial, communication media, exploratory environment, and programming language. This review focuses on tutorial and tools, or a combination of these two types of technology. Tutorial describes programs that teach mathematics where information, demonstration, drill, and practice are given to students. This type of CT includes mathematics games and drill and practice software. Tools serves to make teaching and learning fun, effective, and efficient. Virtual manipulatives and instructional management software such as Accelerated Math, STMath, and Dreambox are some examples of this type of CT. The use of this software allows teachers to match instruction with an individual student's skill level, providing appropriate practice while monitoring student progress. Tutorial. There is a significant amount of research to support the potential of using games as an educational tool. Digital games can be powerful in presenting complex mathematical concepts and can be viewed as a cognitive tool promoting achievement in a variety of skills. In game-based learning, gaming is not delivered as a reward after students have completed an assignment, but as a way to interact with and engage with necessary mathematical content. Educational content is integrated within the game, and game goals and learning goals are aligned. Afari reports that students who are involved in mathematics games perceived statistically significantly more teacher support, involvement, personal relevance, enjoyment of mathematics lessons, and academic relevancy. STMath is a digital mathematics software currently used by about 473,300 K through 8 students at 1,355 schools in 24 states, including Texas. ST Math uses images to help students develop spatial temporal reasoning to help lead to more complex understandings of mathematical concepts, including fractions, proportions, symmetry, and other arithmetic problems. The game-like exercises are formulated to engage and motivate students to solve mathematics problems. As students complete each level, they progress to a new, more difficult level. The software provides teachers with data on individual student progress to help to identify struggling students. Software such as this gives teachers the means to provide differentiated instruction to students with varying abilities. This is a program used regularly in my classroom and can be highly personalized to each student's needs. Students gain understanding as well as procedural and computational skills. The data retrieved from the program allows me to identify what students are struggling with so that I am able to address misconceptions. Games can help to increase student retention of information as they actively participate in the learning process. Tools. Manipulatives have historically been used to help build a strong foundation for students to understand abstract concepts. Virtual manipulatives are a type of computer technology tool and are replicas of real manipulatives accessed via the internet. SUH defines virtual manipulatives as an interactive, web-based visual representation of the dynamic object that presents opportunities for constructing mathematical knowledge. One advantage of virtual manipulatives is the capability of connecting visual images with abstract symbols, a limitation of regular manipulatives. Another advantage is virtual manipulatives gives user control and ability to manipulate objects and to provide opportunities to explore and discover mathematical principles. A study done by SUH found that the manipulatives could effectively be used to teach fraction concepts to elementary students. The participants of the study were 46 fifth-grade students in 3 classes. The study focused on the use of virtual fraction manipulatives for understanding fraction equivalence and addition. The applet used in the first task for renaming fractions allowed students to manipulate an up and down arrow key that divided each region into multiple parts. The teacher assigned 5 problems and asked students to record their work on an answer sheet. Students recorded equivalent fractions such as 1/2 is equal to 4/8 is equal to 3/6 is equal to 4/8. During the discussion at the end of the class, students explained the way they used the virtual manipulative applet for finding equivalent fractions. Students defended and challenged their peers' rules for finding equivalent fractions. One student found a pattern of repeated addition of numerators and denominators, while another named it finding all the multiples for the numerator and the multiples for the denominator. The renaming fraction applet supported student learning by allowing discovery learning and encouraged students to see mathematical relationships. The applet used in the second task for fraction addition allowed students to use the arrow key to search for a fraction denominator that was common to both fraction pieces. Students could visually see how the total number of pieces changed on each of the fractions as they used the arrow button. When the check button was blocked, students received immediate feedback. Empirical investigations show that students learn best when the tutor provides immediate feedback consisting of short and directed error messages. The students' written work indicated that using the virtual fraction applet gave them the opportunity to attach meaning to fraction symbols. The link between the visual model and mathematical symbol provides support for students. While there is a significant amount of research on computer technology, there is a lack of information on how the success of technology use and student achievement may depend on their gender, grade level, ability level, and socioeconomic status. To have a fuller understanding of the impact of CT, further research would need to broaden outcome measures in both cognitive and affective domains as a way to provide comprehensive information on how CT may affect mathematics learning. Technology has become essential in teaching and learning and can play a major role in making sense of mathematics. Computer technology should be a necessary component of any good teaching. Computer technology can help teachers to engage learners and explain difficult concepts. Students' use of technology in appropriate ways persist longer, enjoy learning more, and demonstrate gains in mathematics performance. However, teachers are still the main factor in student achievement. Teachers still make learning possible by transferring knowledge, skills, and value to all students.